Hi students. So till now in the previous sessions we have discussed about the surface areas and volumes concept, areas, surface areas and volumes. So today we are going to discuss about the other topic, that is a new topic, which is areas of parallelograms and triangles. Areas of parallelograms and triangles. As we know already, what is a parallelogram and what is a triangle? A three-sided closed figure. Three-sided closed figure. This is three-sided closed figure. So three-sided closed figure. This is called a triangle. A, B, C, which is having three sides. So this is the triangle. Then a parallelogram. So parallelogram, even in class 8 we have discussed, as well as in class 9 in the previous chapter, that is 8th chapter I think so, quadrilaterals. In that we have discussed about the parallelograms. A parallelogram is a quadrilateral with opposite sides are parallel. Opposite sides are parallel. These opposite sides are parallel, and when it comes to the special properties of it, they opposite sides are equal. This side is equal to this side, and these two sides, opposite sides, are equal. And we know in 8th chapter we learned diagonal of a parallelogram. Diagonal of a parallelogram divides. Diagonal of a parallelogram divides that into two congruent figures. Diagonal of a parallelogram divides that into two congruent figures. What exactly congruent figures? What exactly congruent figures? The figures which have same shape and size. The figures which have same shape and same size. Observe it. These are the staple panes. See this one, the figures, they both, observe the plane surface. I am talking about this plane surface. You see here, plane surface. So they both have the same shape and same size. When you keep one upon the other, now you see, they both are, each and every corner of the staple box is coinciding with each other of the other staple box, the pins box. So here these two figures are said to be congruent. When do we say they are congruent? When do we say they are congruent? They must have same shape and same size. So congruent. Congruent. When do we say same shape? Same shape and the same size. Same size. Now, same size. Congruent figures will have equal areas. Just now I showed you, these two are, they have this area of this figure plane and area of this plane. They both are same. They both are same. When you are placing one upon the other, so they are coinciding each other. So congruent figures will have equal area. Next, congruent figures will have equal area. Now, equal area. Okay. If the areas are equal, okay, this is, so diagonal of a parallelogram divides that into two congruent triangles that we learned in the earlier classes. So area of this is equal to area of this, that is area of triangle ADB. Area of triangle ADB is equals to area of triangle CBD. So those two areas are equal. The areas will be, area we denote with AR. Area we denote with AR. So these two areas are equal. Now Observe this figure, rectangle. Observe this rectangle and observe this square. Here, observe the square. Here I am taking the side. Look at this. Length is 6 cm and breadth is 4 cm. What is the area of this rectangle? Area of this rectangle is L into B, which is 6 into 4. L into B, which is equals to 6 into 4 is equals to 24 centimeter square. And side of the square I am taking as 6 centimeter. Side of the square is 6 centimeter. Area of the square, this is square and this is rectangle. This is square and this is rectangle. So area is side into side as we know. So side is 6. Side is 6. 6 into 6. 36 centimeter square. Are these two areas are same? No. Areas are not same. Now I will explain one more. Here. Now observe this figure which I am taking. This is a rectangle. This is a rectangle. 8 centimeters. 9 centimeter is this length. 9 centimeters is the length and 8 centimeters. 8 centimeters if you take 9 into 8 centimeters. 9 8s area is equals to 72 centimeters. 72 centimeters. See, now I am taking another rectangle. 9 into 8, 72 centimeters square. Now I am taking another rectangle which is having 18 centimeters length and 4 centimeters breadth. So its area is equals to 18 4s are 72 centimeters square. Are these two figures congruent? Here I wrote congruent figures will have equal area. Now areas are equal. Do you agree that these two figures are congruent? No, you are right. That is, if areas are equal, need not to be congruent. If the figures are having same area, then they need not to be congruent. What is exactly area? The region, space occupied by a closed figure. The region occupied by a closed figure is called area. It is measured in terms of the numbers as square units. It is measured in terms of numerical. In terms of numericals and square units will be added. Area always will be measured in square units. In terms of numerically we calculate. So area is nothing but the space or the region occupied by a closed figure. It may be any shape. The area occupied, the space, the region occupied by a closed figure on the plane surface. In a plane surface, that is called its area. Now these two are same area but they are not congruent. So here we can say that if areas are equal, the figures need not to be congruent. If areas are equal, figures need not to be congruent. So area is nothing but which is having a closed figure which covers the region. That complete region is called area of that particular figure. Now we are talking about areas of parallelograms and triangles. So before that, I just wanted to say, we'll discuss with one of a small example. Suppose a lady or an old man or an old lady is there. She has three children, two daughters and one son for her. The property, the land what she had, that she wanted to divide, the land which she is having, it is in a triangular space, So this is the land, if you think, triangular space. She wanted to divide the land equally for her two daughters and one son. How can we divide? But that's what. Then the topic, then the concept of area. Because two daughters and one son, they have to get equally. They have to get equal area. The reason, see here, though the measures are different, they have equal area. So she has to distribute the space, the region of the land what she has among those three children, two daughters and one. So what she did, she just joined the triangular region, the land which she had. This is the land what she had. She just joined from 3 points. She located one here and one here. Okay, and she just joined like this. So, and she told this is for the daughter one. This is for daughter, and this is for another daughter, and this is for son. The leftover is son. So, do you agree? It may be, but her intention is, she has to distribute equally among all the three children, that is two daughters and one son. So she just located the points on the base like one side, and those 2 points she just directly joined to the opposite vertices, and she said these are the 3 parts. You can now onwards you can cultivate those lands. I divided it into 3 equal parts. So area, the concept, she divided something are the measures, whatever she did, she divided that into 3 equal areas. So if areas are equal, the figures need not to be congruent. The areas are equal, the figures need not to be congruent. Congruent figures will have equal areas. So why areas topic, rectangular, triangle and parallelogram? Why this especially we are discussing areas of parallelograms and triangles. In this, how she divided this triangle, you see, the land whatever she is having, she just kept the 2 dots and she joined to here. The same, whatever the land she is having, that 2 points she located and she divided it into 3 equal parts. So with the concept of all these areas and congruent figures, now we are going to discuss about areas of parallelograms and triangles. In that we will see the parallelograms and triangles, whether they are different parallelograms or they have any common terms in those parallelograms or in the triangles. Let us discuss those parallelograms and triangles. Now we see figures on the same base and between the same parallels. Figures which have the same base and between the same parallels. So here we have 2 different types. Here one set and here this is another set. You see here a trapezium or a parallelogram, whatever the quadrilaterals here we have A, B, C, D, and DCFE. DCFE or CDEF. They both are lying on the same base is same. They are standing on the same base. So same base DC. Same base DC. And you see even in the figure, in this one, PQRS and SRNM, they both are on the same base SR. They are standing on the same base. Then triangle, look at this, triangle ABC and triangle DBC, they both are standing on the same base. They both are standing on the same base. Now you see to the next bit here. Figures A, B, C, D and F, B, C, E. B, C, E, F and A, B, C, D, they both are standing on the same base. They both are standing on the same base, and here these lines are parallel. Actually these are the two parallelograms. These are the two parallelograms. This is parallel to this. This is parallel to this. And here, so they are parallel. This line is parallel to this line. Observe it. So they both same base BC and between same parallels AE and BC. They both are having the same base BC and they are in between same parallels AE and BC. Now, second figure you see, ABCD is a trapezium and DCFE is a parallelogram. They both are standing on the same base. They both are standing on the same base DC and they are lying in between same parallels AF and DC. AF and DC. Now come to the next one. Come to the next one. See, triangle PQR and triangle SQR, they are standing on the same base QR, but the triangle vertex S is here and P is here. They are not on the same between same parallels. They are not on the same between same parallels. They are not between same parallels. See here. In the first one they are lying on the same base, and in the second type we are saying they are on the same base and between same parallels. They are on the same base and between same parallels. They are on the same base and between same parallels. These two, whereas here they have the same base and they do not have, they are not between same parallels. They are not between same parallels. So now in this you see both AB, ABCD and FBCE or BCEF, they both are parallelograms. They both are parallelograms. So now when it comes to the topic of parallelograms, what happens? What is the special quality if they lie? What is the property? Why we are talking about they are on the same base and lie between same parallels? They are on the same base and lie between same parallels. What is the special quality in it? So the parallelograms which lies on the same base and which have the same base and which lie between the same parallels. So what? If they lie on the same base, will lie between same parallels, what happens? That we are going to discuss in the next, that is the parallelograms which have the same base and lie between same parallels will have areas, will have equal areas. So parallelogram ABCD and parallelogram BCEF are on the same base BC, lie between same parallels BC and AE. Therefore, they both will have equal area. How they both will have equal area, that we will discuss later. That we will be discussing after this. Do you understand what is the same base and what between same parallels? Here they are on the same base, and in this the figures are on the same base and lying between same parallels. Here it is on the same base but not between the same parallels. Do you understand? Now here you see in the graph paper we have some figure. Parallelograms on the same base and between the same parallels. If two parallelograms are having on the same base and lie between the same parallels, this is an activity which have the same base. You see parallelogram A, B, C, D and parallelogram PQCD. They both are on the same base DC and lying between same parallels DC and AB as DC and PB. Both the parallelograms are on the same base DC and they are lying on the same parallels DC and PB. Now count the area. How do you measure this area? By counting the square boxes. By counting the square boxes, you see in triangle, we are finding even triangles also. Triangle APD and triangle BQC. Exactly, if you count those areas, that square boxes, they both are equal. And a common portion in both the parallelograms, what do you have? It is appearing like a trapezium. It appears like a trapezium. So for the triangle, if you add area of this trapezium, these two objects, which triangle? APD. In triangle APD, how many square boxes, full boxes and half boxes? Plus in trapezium AQCD, if you add those two, that will be equal to the triangle QBC plus the boxes in AQDC. That is one way. Another way, you count the boxes, full boxes of parallelogram ABCD. Count the full boxes of parallelogram ABCD. How many full square boxes, how many half boxes are there? And now you count again the boxes full and half in PQCD, parallelogram PQCD. Both the parallelograms ABCD and PD. ABCD is one parallelogram and PQCD is another parallelogram. They both are on the same base, lie between same parallels. If you count this number of square boxes full and half, their area will be equal. So with this, what we can conclude? The parallelograms which are on the same base lie between the same parallels. Parallelograms which are on the same base lie between the same parallels will have equal area. Let us discuss how the area will be equal. We have a theorem. We are going to prove that now. Let us see how those parallelograms which they have the same base lie between same parallels, how the areas are equal. Now, theorem 9.1. Parallelograms on the same base and between the same parallels are equal in area. So how these areas are equal? So given that two parallelograms, so what is, first you write given parallelogram ABCD, parallelogram ABCD and parallelogram DCFE. Observe it. Parallelogram ABCD and parallelogram DCFE are on the same base. What is the same base here? BC. And between same parallels. What are the same parallels? DC and AF. These are the parallels. DC is parallel to AF, same parallel lines, and they are on the same base. Now we have to prove that. Required to prove. What we have to prove? Required to prove area of ABCD parallelogram. Area of parallelogram ABCD is equals to area of parallelogram, that is DCFE. Area of DCFE. Observe it. DCFE. Clear? AR meaning is what? Area. So for that, what we are doing? Proof. Observe the proof carefully. See here, angle, this angle and this angle. Angle DAE is equals to angle CBF. Angle DAE is equals to angle CBF. Reason is what? Reason, these two, what can you say? The lines are parallel. DA and BC are parallel. Why they are parallel? ABCD is a parallelogram and AF is the transversal. These are, what do you call these angles? These two lines are parallel and these are angles are equal. This is AF is the transversal. What do you call? Corresponding angles. Let this as one. Corresponding angles. Okay, corresponding angles. If they are corresponding angles, which are the lines parallel? Here I am writing DA parallel to CB, DA parallel to CB, and AF is transversal. Now, this is the reason for this. Now, one more. Angle, observe it. Now again, which angles? This angle. I am taking this angle and this angle. Angle AED. Is equals to angle BFC. This is 2. Reason again, corresponding angles. Here, which lines are parallel? DE and CF. So CF parallel to DE because CF parallelogram ABCD and parallelogram DCFE, they both are parallelograms. We know parallelograms, opposite sides are parallel. And another properties we have, opposite sides are equal also. So here CF is parallel to DE and AF is transversal. Now you observe in triangle ADE and triangle BCF, Now, in triangle ADE and triangle BCF, correspondingly this angle is equal to this angle is equals to this. So means two angles are correspondingly equal by angle sum property. What can you say? By angle sum property from 1 and 2, from 1 and 2, what can you say? Corresponding angles are equal. We use that property. Now, triangle ADE and triangle BCF, angle sum property. If this angle is equal to this angle is equal to this, then what can you say about the third angle? Third angle is equal by angle sum property. By angle sum property. So in triangle ADE and triangle BCF, from 1 and 2, we can say that triangle ADE is equals to angle BCF by angle sum property. Angle sum property. Angle sum property. Sum of the three angles in a triangle is 180 degrees. As this angle is equals to this and the second angle is equal to this, two angles are correspondingly equal. So by angle sum property we can say that the third angle will be equal. Now, when the three angles are equal, now you see the triangles. Now, consider triangle ADE and triangle BCF. As we know, just now we proved angle ADE is equals to angle BCF, and here we got DAE is equals to CBF and ADBC are equal. AD and BC opposite sides of parallelogram. So when you are considering these two triangles, angle DAE is equals to angle CBF. This is angle. Next, side AD is equals to BC. These are corresponding angles we proved just now here. Okay, now side AD is equals to AD is equals to BC. This is side. Opposite sides of parallelogram are equal. Next, now we have one more angle. Just now we proved ADE. Angle ADE is equals to angle BCF. This is the angle. So by ASA criteria, the two triangles are congruent. Which two triangles? ADE. So triangle ADE is congruent to triangle ADE is congruent to triangle BCF by ASA congruence rule. Once the triangles are congruent, their areas will be equal. We discussed congruent figures will have equal areas. So therefore, we can write area of ADE is equals to area of BCF. Area of ADE is equals to area of BCF as the triangles are congruent. Now you see in both the figures, parallelogram ABCD and parallelogram DCFE, they have some common portion in that. So this is the common portion which you are observing. Both the parallelograms are having some common portion. So this is the common portion which we are going to add for both the triangles. Now you take area of triangle ADE. For that I am adding ADE triangle. For that I am adding DCBE area. So area of, observe it, area of ADE plus area of ADE plus area of EDCB, area of DCBE. This is the portion. If you add, which area you will get? If you add area of ADE plus this one, so area of, observe it, area of adding this area. Okay, so we are adding the area for both, that is the common portion for both we are adding. So common portion, adding area of, what is the area? EDCB, area of EDCB, both sides for, here we wrote 1 and 2, and for we take this as 3. We take this as 3, 2, 3. Adding area of EDCB, common portion EDCB to the equation 3. Now you get area of ADE plus area of EDCB, which we are adding, area of EDCB is equals to, you observe it now, for this area of BCF plus area of EDCB. Now think about it. Area of ADE plus this portion, which figure you are getting? That is ABCD. So area of parallelogram, area of ABCD is equals to, now the same area you are adding to this because these two areas are equal. This area and this area are equal. So we are adding the common portion. So which you get area of DCFE. So area of DCFE. Now you see both the parallelograms area is equal. So proved. Hence prove. What actually we have to prove? We have to prove their areas are equal. So for that what we did? We took first corresponding angles are equal, and this corresponding angles are equal. By angle sum property, the third angle is equal in triangle ADE and triangle BCF. If the triangles are congruent, their areas, congruent figures will have equal area. Congruent figures will have equal area because the triangles are congruent. For those two areas, because these two areas are equal, we are adding the common portion, that is a common portion EDCB for this triangle and for this triangle. Then we are obtaining that the parallelograms areas are equal. So with this, what is the conclusion? Parallelograms which are on the same base lie between same parallels. Parallelograms which are on the same base lie between same parallels will have equal areas. Is it clear, students? How we are getting the parallelograms if they have same base and lie between same parallels, how the areas are equal. Is it clear to you? I hope you understood. Yes, we will continue the next leftover in the next session. Thank you.